Welcome to the Explainer. So grab your calendar and take a look at June 19th. It might seem like just another ordinary day, right? But honestly, it is arguably one of the absolute greatest dates in the entire history of mathematics. It's literally a golden day, and today we're going to dive into exactly why that is. June 19th in 1623, 1771, 1901, and 1941. On this exact date, across totally different centuries and continents, brilliant minds were born who fundamentally engineered the modern world we're living in right now. We're going to trace this timeline, starting way back in the 1600s and building up to the modern era, meeting these incredible minds one by one.
Okay, to kick things off, have you ever actually stopped to wonder how your phone handles massive, super complex calculations in literally a fraction of a second? Or, hey, how your favorite video game calculates the exact probability of a super rare item dropping?
Well, the answer takes us all the way back to June 19, 1623, and a guy named Blaise Pascal. Pascal invented the Pascaline in 1642. This was the very first digital mechanical calculator, and he actually just built it to help his dad collect taxes. But, his curiosity definitely didn't stop at simple addition. He went on to lay the core mathematical foundations for probability theory. Basically, he figured out the math of chance and predictability, and that exact math is the engine powering the insanely complex algorithms of our modern computing today. The huge takeaway here is that every single time you roll the digital dice in a game, Pascal is actually the one doing the math right there behind the screen.
Still on June 19th, but now we're jumping forward over 100 years to 1771.
Think about the mind-blowing 3D world in the video games we play or the movies we watch today. Have you ever wondered how your TV or your phone actually manages to project all that breathtaking depth perfectly onto a completely flat 2D screen? It's kind of wild when you really think about it.
The secret behind that trick goes back to June 19th, 1771, and a brilliant French mathematician named Joseph Gergonne.
Gergonne was an absolute pioneer of what's called projective geometry. He discovered this thing known as the principle of duality. In simple terms, he proved that points and lines are actually interchangeable in geometric theorems. By figuring out how to connect points and lines to translate shapes, he pretty much wrote the mathematical rulebook. We need to take complex, three-dimensional structures and project them accurately onto flat surfaces without losing any of their proportions.
To put it as simply as possible, his work is literally the math that makes our flat screens look deep and real. Same date, exactly 130 years later, we are traveling over to India for a really, really big idea. Have you ever wondered why a super scratched up QR code still scans perfectly on your camera? Or how you can be listening to Spotify and the music sounds crystal clear, even when your Wi-Fi is totally glitching out and dropping packets of data left and right? We can thank June 19, 1901, and an absolutely incredible mind named Raj Chandra Bose. Bose worked on this groundbreaking theory called error-correcting codes. It's a brilliant mathematical system designed to automatically fix digital glitches and background noise. Think of it kind of like a self-healing puzzle. When bits of data get lost in the air because of a spotty signal, his mathematical formulas can automatically deduce exactly what's missing and magically reconstruct the data. This exact math is what powers our modern Wi-Fi signals and digital scanning, keeping them totally flawless. Because his work relied so heavily on mathematical symmetry, it really makes you think, what if the beautiful symmetrical pattern of a snowflake is the exact same kind of math hiding inside your Wi-Fi signal right now? I mean, that's the pure beauty of Boser's work. One date, so many incredible stories. But let's make one final jump forward to 1941. How does a single WhatsApp message instantly navigate billions of different internet connections to find the absolute fastest route to your friend's phone on the total opposite side of the globe? The answer brings us right back to June 19, 1941, and an English mathematician named Derek Waller. Waller mapped out incredibly complex telecommunications networks. He used this field called graph theory, which, by the way, is basically the study of nodes and the lines connecting them, to analyze multi-stage communication networks. By mathematically calculating the absolute shortest possible paths through massive webs of connections, he engineered the underlying logic that makes high-speed global routing possible today. And because of his engineering, your instant messages literally travel the world on invisible mathematical bridges. June 19 in 1623, 1771, 1901, and 1941. Every single person we've talked about today from totally different centuries and different countries all shared one massive, overarching goal.
They all looked at the world and asked the exact same thing. What is the pattern hiding inside the chaos? And honestly, because they dared to ask that question, we now have calculators, 3D graphics, flawless Wi-Fi, and a globally connected internet. So it really leaves you wondering, as we push further into the age of AI and quantum computing, what invisible patterns are hiding in our world right now, just waiting for the next brilliant mind to discover them?